Okay, everybody, this is your little review for your quiz tomorrow. Excuse me. I'm going to go over some of this stuff with you. I'm not going to go through it all because of the examples that I give will serve as examples for everything else. Okay, so here in the first section, you have to write the full electron configuration for these elements right here. And we have cobalt in the first one, and cobalt happens to be number 27 in the periodic table. So 27 electrons have to be present. So we're going to write, we always start with 1s2, right? Then 2s2, then 2p6, then 3s2, then 3p6, and 4s2. And now when you get to the D block, you go down one. And meaning that the 4 is not 4 anymore, it'll be 3. So it'll be 3D, and I believe that's 7, so 3D7. Make sure that when you go from the S block to the D block, that you take your number that you're given, the period number, and subtract 1. So if you're moving from 4, you're in the fourth period, and you're in the D block, it's going to be 3. Aluminum is number 13 in the periodic table. And its full electron configuration is 1s2, 2s2, 2p6, oops, excuse me, I'm right, 3s2, 3p1, all right? It's in the third period, it's in the p block, and it's the first element in the p block. And if you follow that pattern, you can figure out all the configurations for any element you want. Now, noble gas configuration, you got to make sure that whatever element you're looking at, you go up one row, and then you go all the way to the right to find that noble gas. Well, cadmium happens to be number 48 in the periodic table. If we go up one from cadmium, we go all the way over to, hold on a second, where am I at? Okay. We go all the way to, let me get it there. There we are. Cadmium to krypton. So krypton is where we start. All of those noble gases are in group 8, not period 8, but group 8. So that krypton in brackets means everything up to krypton has been taken care of. We don't have to write anything. We don't have to start with 1s2, 2s2, or anything like that. So now we have to write whatever comes after that all the way up to and including cadmium. So it would be krypton, and that would be 5s2, and then it drops down to 4, so it would be 4d, and if you count that, you count the number of elements all the way through there, you get to cadmium, it would be 4d10, okay? Strontium is very easy. The element that is in the noble gases in group 8 would be krypton again. And you write whatever's after that, and strontium would be a simple 5s2. Okay? And you can figure out the rest. The number of total electrons in the following configurations, the way you do that is by looking at the exponents that you see here. You add them all together. And so 2 plus 2 plus 6 plus 2 plus 5. So that's 10, 17. 17 total electrons for number 11. For number 12, that'd be 2 plus 2 is 4. That's 10, 12, 18, 20, 30, 6, 37. Okay? There you go. All right. The number of valence electrons, you need to look for the highest energy level. Or it could be levels, we don't know, unless we look at the electron configuration. Let's start with 14. The highest energy level is 3s2. All right, so now all you got to do with that is look at the exponent, and that will tell you how many valence electrons are present, and that would be 2. For number 13, the highest energy levels present are 4. A 4s2 and a 4p5. They are the highest. So all you do is you take the 2 and the 5 and you add them together, and that gives you 7. Please know that red, orange, yellow, green, blue, indigo, violet is your Roy G. Biv. And the one that has more energy on this, green or yellow, that would be green, because there is more energy on the violet side of the spectrum and less energy on the red side. And number 16, which has more energy, orange or red, that would be orange, because orange is closer to the violet side than red is. And we answered this in class today. When we see color, what happens? And this has to do with electrons. Electrons absorb energy. Absorb, that's a B. Absorb energy and release it. And that's how we see light and color. Okay? Number 18, how many electrons can be held in the s orbital, the p orbital, and the d? Well, for the s, that would be 2. The p orbital, that would be 6. And the d orbital, that would be 10. That's what we do every day. For example, 1s2, 2s2, 2p6, 3d, 10. There we are. How can the relationship between wavelength and frequency be described? If the wavelength goes up, frequency goes down. It is an inverse, and that's the key tomorrow, inverse, which means indirect. It is not a direct relationship. It is indirect, not direct, not direct. So if the wavelength goes down, then the frequency will go up. Okay? And number 20, what color of the visible light spectrum has the greatest energy and the shortest wavelengths? That is the violet end. Okay? We're not going to use purple, we're going to say violet. Labeling the wave, crest, trough, wavelength, and amplitude. Here we go. Draw the midline, showing the direction the wave is moving. And then we draw the wave. Okay? The crest, with a C. The trough, with a T. The wavelength, I'm going to draw the different color, is either crest to crest or trough to trough. And the amplitude is the height of the wave from the midline or the depth of the wave from the midline. It's a pretty easy quiz. Study a little bit. Think it'll be all right. And have a good night.